Hey everyone, it's Darren. Welcome. Today we're going to be talking about odds. And it's something that when you're working with data, no matter what you're doing with data, a lot of times you're wondering, what are the odds of this happening? What are the odds of this not happening? Uh, and really, odds even come into play in a lot of places you wouldn't expect them to come into play. There's a lot of different factors that go into odds. This video, we're going to be looking at one specific type, which is the type of odds where you get from rolling dice, flipping coins, that sort of thing. Each individual element here is a fair, even odds. So if you're rolling dice, there's a 1 in 6 chance that each die will come up with a 1. 1 in 6, it'll come up with a 2. 1 in 6, it'll come up with a 3. If you're flipping coins, 50-50 chance you get heads, 50-50 chance you get tails. And do it over and over, and you keep getting those same odds for each individual. Now, when you start to combine things, your odds start to look a little different. And that's where people can get a little confused sometimes. So let's take a look at an example here. Let's bring up an example with simply one die. Okay, so if we're just rolling one die, we could have 1, 2, 3, 4, 5, or 6. And that's all we can get, right? And if we want to total up these dies, we'll have sum of A2, and I'm doing that for a reason. And there's our totals. So we have totals 1 through 6. Now I'm going to actually look at the possible values. What are the possible values in our total column here? Well, again, that's 1, 2, 3, 4, 5, and 6. Those are the only possible values. And so far, this is looking really, really simple. And like I said, I'm doing that on purpose because if you look at the tabs at the bottom, it's going to get more complex here in a minute. I just want to make sure it's really easy to follow. And that's also why I'm doing the formulas instead of just typing in the numbers. And now COUNTIF, if you haven't seen this, there's a video linked in the description on COUNTIF. Um, COUNTIF, and our range is going to be $2 to $7. And our criteria is going to be C2, which is why I put that column in. So this is telling us that we have one that has a value of 1. Okay, well, let's just copy that down. I have one that has a value of 2, one has a value of 3, one 4, one of 5, one with 6. And I've given every possible option for these dies. These aren't random numbers. These are just straight numbers typed in. And now if we take a look at all the possible options, and let's go ahead and insert a graph here. Let's just do a quick line graph. And that's not a real exciting line graph there, is it? And the reason it's not real exciting is pretty obvious. The data's flat, and you'd expect that. And this is telling us that this data is actually pretty fair roll of the die. If you had random data and you had enough rolls, your graph would come out looking very similar to this. It might have a little bit of waviness to it, but it should be really, really close to this, as long as you're rolling fair dice. Okay, so that one's simple, right? Well, what if we roll 2 dice? What do you expect will change? Let's take a look. Okay, so here we have 2 dice, and what we have is all possible permutations of 2 dice. So each one can go 1 to 6, and I've already put in all the permutations here. And the total column, just like it was over in the other one, is the sum when you add these together. Now, if we look, there's 0 options that will come up with a 1. You can't roll a 1 and a 0 unless one falls off the table, I suppose. For 2, the only option you have is if you roll a 1 and a 1. For 3, you have 2 options. And this is where Some people start to make mistakes with calculating odds. So to get three, you can either have a one and a two, which gives you three, or you can have a two and a one, which also gives you three. And some people are thinking, well, that's one and two, and it's really not. It's actually one and two and one, which are different. If you have two separate die and you roll them both together, uh, let's say make one of them red and one of them white, just so that they're different colors, and you roll them, you could have a one on the red and a two on the white, or you could have a one on the white and a two on the red. Two different outcomes come out to the same result, comes out to the same value, two different outcomes. Well, what about three? Well, sorry, what about four? Well, for four, you can have one and three and one, or two and two. Gives you three. And you'll notice that these are actually very symmetric if you skip down here to the bottom. So for two, there was one option. For 12, there's one option, six and six. For three, there's two options, which is one and two, or two and one. For 11, there's two options, which is five and six, or six and five. And it kind of maxes out here at seven. So there's six different ways you can get a seven. You can get a one and six, or a six and one. You can get a two and five, or a five and two. You can get a three and four, or a four and three. So you have six different ways to get a seven, and that's the largest number of, uh, that's your best odds of hitting a seven with rolling two dice. Well, what if we graph these? This one sort of surprised me when I saw it. So let's throw a same line graph in here. And you get a triangle. Now, if you saw my earlier video on a normal distribution, you're probably expecting that you would get something that looks like this. This is what things look like if you throw enough random data out there, you get something that looks like this. So why aren't we getting something that looks like this? Well, we don't have that much data yet. That's the problem. So just like if we go back over here to one, that certainly doesn't look like a nice bell curve. And the reason is there's almost no data. We roll two dice, and now we get a triangle. Doesn't look much more like a bell curve, to tell you the truth. Um, what if we add a little more data? Let's roll three dice. Okay, so for three dice, obviously we can't get a one or a two. Uh, one way to get a three, and one way to get an 18. Three ways to get a four, three ways to get a 17. Five ways to get a six, excuse me, six ways to get a five, and six ways to get a 16. And we can look through these and see what each of these options is. And this is exactly like the previous two. This is just all possible permutations of three die. Three dice. So yeah, so I go down 36 options, 36 rolls where die number one is a one. There's 36 more where die number two is a two. So here we max out at 10 and 11. We have equal odds of being either a 10 or an 11, and those are right in the middle. So what if we graph this one? Let's do a graph here. So let's insert the same graph, and now it's starting to look a little bit more like that bell curve, isn't it? And we did exactly the same thing. We just listed all possible options for three different die being rolled, or you get the same thing rolling one die three times. So it's three options, three different die. So this is looking a lot more like what we are expecting for random data, random distributions. Uh, it's exactly what we did in one die, exactly what we did with two dice, But with three, now you've actually almost got this bell curve. If we flip back over to that bell curve, you know, that's looking pretty close now, isn't it? And we're only looking at three data points, three data items. So let's come back here and let's take a look at four. And the same thing here, except now we have 1,296 different possibilities. You're still symmetric. Your best odds are hitting a 14 if you're rolling three dice. Um, so let's take a look at what happens if we graph this. So we'll insert this graph again. And very similar, but take a look. If we flip back and forth, see this one's a little bit flatter, and this one's a little bit steeper here on the sides. One thing to keep in mind, I'm actually graphing all the way down to one. Probably it'd make almost more sense if I just graphed it from that option. So let's just graph that option instead. And now if you look here, this is looking very smooth, very clean, and really it's very much like what we saw before. And you kind of get that as soon as you hit even just three dice. And if you're running with a lot of data, you're going to hit this really quick. Now, this is all every possible permutation. This is what you will get if you use a large enough set of random rolls. If you do a small set, it won't. Think, for example, if you flip a coin, you get heads, you have 50-50 chance of getting heads. If you flip the coin again, you're not guaranteed to get tails. You get heads again. You can flip the coin 100 times in a row and get heads every single time. The odds are against it, but you can do it. And that's why when you're looking at a lot of data, you need to like the bigger the data set you have, the better. And when you get a big enough data set, your data really tends to head towards this normal distribution curve. Now, we'll add for this video, all of the data we're talking about can repeat. You roll a die, you get a six, you roll a die again, you get a six, that's fine. The other way that data works quite often is that you can't repeat data. And when you'll see that is if you're playing bingo and you have this bingo cage and you roll it and you pull out B15. Okay, well, your odds of getting a B15 were 1 in 75. There's 75 balls in there. So you set the B15 down, you roll the cage again, you reach in, 0.75. Okay, well, your odds of 0.75 when you started were 1 in 75. Because you've already pulled out the B15, your odds are now 1 in 74. Roll it again, B2. Okay, well, your odds of pulling that B2 at that point were 1 in 73. We'll do another video on that later. The math gets a little trickier. Uh, with being able to repeat data like this, it's a little bit easier to conceptualize. When you can't repeat values, that's a little trickier, but it does come up a lot as well. So that's what I have for you today. Hopefully you learned something. Hopefully that this helps. Uh, again, there's a link to the COUNTIF video down in the description if you'd like some more information on that and SUMIF, and there's a bunch of functions like that. If you learned anything from the video, if you enjoyed it, please click the like button. It really helps out the video a lot. Also, be sure to subscribe and hit notify so you can see when I release new videos. We have a Patreon page at patreon.com/data analysis excellence as well. It'd be great if you could help out the channel that way. And hope you have a great day. Thanks for stopping in.